Welcome to the peaceful space of sleep-friendly science, where we will journey thousands of meters below the waves to a realm of crushing pressure and eternal night, seeking the majestic titans of the abyss. Imagine floating weightlessly, sinking gently past the sunlit surface into a world of perpetual twilight and then utter darkness. In this mysterious kingdom, where the weight of the ocean is immense, strange and wonderful giants roam. Let your curiosity drift with us as we explore this fascinating enigma. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Crushing Descent. Your journey begins not with a sudden plunge, but with a gentle surrender. You are floating, weightlessly, in the sun-drenched upper layer of the ocean, the epipelagic zone. The water is warm, a familiar and comforting caress against your skin. Above you, the sun is a brilliant, shimmering orb, its rays piercing the surface and scattering into a million dancing diamonds of light. This is a world teeming with life we know, a vibrant, chaotic symphony of color and movement. The water itself feels light, buoyant, a cradle that rocks you softly in the rhythm of the waves. The pressure here is negligible, something your body understands and is perfectly attuned to. It is the pressure of one atmosphere, the gentle weight of the air that has blanketed you for your entire existence. You take a slow, deep breath, and you let it go, feeling the last of your tension dissolve into the vast, blue expanse. Now you begin to sink, slowly, effortlessly, as if the ocean itself is gently pulling you down into its secrets. The first 10, then 20 meters pass. The light changes. The brilliant, warm yellows and reds are the first to be filtered out, absorbed by the water above. The world around you begins to shift into a spectrum of blues and greens. You are leaving the familiar surface behind, entering a realm of deepening twilight. This is the beginning of the mesopelagic zone, the twilight world, stretching from 200 meters down to 1,000. As you drift deeper, past the 300-meter mark, a new sensation begins to make itself known. It is not a pain, not a discomfort, but a presence. It is the first true hint of the immense power you are sinking into. It is the weight of the water above you. Imagine standing on the shore, feeling the air. Now, imagine that air is replaced by water. Every 10 meters you descend adds another full atmosphere of pressure. It's like stacking another sky on top of the last one, and another and another. At this depth, the pressure is already 30 times what it is at the surface. If you were holding a hollow, sealed object, like a plastic bottle, it would already be groaning, its sides beginning to buckle under the immense, even squeeze from all directions. You continue your descent, silent and serene. The blue light grows dimmer, more concentrated, a deep and royal sapphire that seems to be the very soul of the ocean. The vibrant reefs and darting schools of fish have given way to new forms of life, creatures adapted to this dim, high-pressure world. You see flashes of silver, ghostly shapes that flicker in the gloom, and then, the first true magic of the deep, bioluminescence. A sudden constellation of living light pulses past you, a jellyfish trailing stars, a silent, cosmic firework in the eternal twilight. These creatures are the first clue that life has found a way to thrive under this growing weight. You pass the 1,000-meter mark. This is a profound boundary. Here, you have left the sun behind entirely. You have entered the bathypelagic zone, the midnight realm. There is no up or down distinguishable by light, only by the gentle, insistent pull of gravity. The darkness is absolute, a perfect, velvety black unlike anything on land. It is a darkness that is not empty, but full. It is full of pressure. Here, the weight is 100 times that of the surface. 100 atmospheres. Try to feel that, to comprehend it in a way that is not just a number. Imagine the weight of a large truck resting on every square inch of your body. Or picture a cathedral, made not of stone, but of solid water, sitting on your shoulders. It is a force that is difficult for a mind born of air to truly grasp. It is a constant, unyielding, and immense embrace. Why is this pressure so significant? For a creature like us, built with air-filled spaces, it would be instantly lethal. The air in your lungs, the tiny pockets in your sinuses and inner ears, these would be the first points of failure. The immense external pressure would find these pockets of low pressure and crush them in an instant. The very gases that give us life would become our undoing, squeezed into nothingness. The delicate balance of gases dissolved in our blood would be thrown into chaos. We are beings of air, designed for the feather-light touch of the atmosphere. We are simply not built for this. And yet something is. You drift deeper still into the bathyal and abyssal planes 2, 3, 4,000 meters down. The pressure is now 200, 300, 400 times that of the surface. It is a force that can warp steel, shrink a styrofoam cup to the size of a thimble, and extinguish any structure not built to withstand it. The temperature has plummeted, hovering just a few degrees above freezing, a stable, penetrating cold that slows all chemistry, all life, to a glacial pace. The silence is profound, broken only by the imagined, slow-motion beat of the planet's heart. You are now suspended in a world that, by all logic, should be barren. A world of crushing force, absolute darkness, and numbing cold. It is an environment more alien than the surface of the moon. And it is in this most extreme, most inhospitable of realms that the paradox begins to unfold. It is here, against all expectation, that life does not just survive, but achieves a scale of breathtaking grandeur. It is in this crushing embrace that the kingdom of the giants is found. This pressure, this immense, world-defining force, is not just a backdrop to our story. It is the central character. It is the sculptor's hand that has shaped everything you are about to see. It is the crucible in which evolution has forged titans. As you float here, in the cold, dark, heavy heart of the world, a question forms in the quiet of your mind, a question that will guide the rest of our journey tonight. How? How, in a place defined by a force that compresses and destroys, does life find a way to expand, to grow, to become gigantic? The pressure is the lock, but it must also, somehow, be the key. Section 2. First encounter with the Titans. You hang suspended in the immense, silent cathedral of the abyss. The question of how echoes in the quiet of your mind, a thought adrift in the profound darkness. The pressure is a constant, heavy cloak, a reminder of the millions of tons of water held in suspension above you. It is a world that should be still, a world that should be empty. But it is not. Your attention is drawn downwards, towards the seafloor, a landscape of soft, ancient sediment that has been accumulating for millennia, a slow-motion snowfall of organic matter from the world of light so far above. In the faint, ghostly beam of your imagined submersible light, or perhaps just in the theater of your mind's eye, a shape detaches itself from the silt. At first, it is just a flicker of movement against the uniform gray, something your brain struggles to resolve. But as it moves with a deliberate, unhurried grace, its form becomes clear. It is like a creature from a forgotten dream of prehistory. Imagine a common woodlouse from a damp garden, a small, armored creature of segmented plates. Now let that image expand in your mind, stretch it, scale it up until it is the length of your forearm or larger. This is a giant isopod, Bathynomus giganteus, an armored sentinel of the benthic realm. Its body is a series of overlapping, pale, almost opalescent plates, a suit of articulated armor that is both beautiful and functional. It moves on 14 legs, each one picking its way across the seabed with an ancient, ponderous rhythm. It is a living fossil, its design perfected hundreds of millions of years ago, a testament to a form so successful it had no need to change. You watch it, mesmerized. It is a creature born of this environment. Its thick, calcified exoskeleton is not a liability under this pressure. It is a fortress. Unlike an air-filled structure that would be crushed, its body is composed of incompressible fluids and solids, perfectly in equilibrium with the immense force surrounding it. It is a submarine built of flesh and chitin. Its movements are slow, a reflection of the world it inhabits. In the biting cold and the scarcity of food, energy is a currency to be spent with the utmost care. Every motion is economical, every gesture has a purpose. It is a scavenger, a patient janitor of the abyss, waiting for the bounty of a fallen whale or a large fish to drift down from above, a feast that may need to sustain it for months, or even years. In its patient, methodical existence, you see the first answer to the riddle of the deep. Time itself moves differently here. Lifespans are stretched, and growth, unhurried by the frantic metabolisms of the surface world, can continue for decades, allowing for a scale that seems impossible to us. As the isopod continues its slow patrol, another presence announces itself. It does not come from the floor, but from the vast, open blackness of the water column. It is not a slow creep, but a sudden, breathtaking appearance. A shadow, darker than the surrounding dark, resolves into a form of impossible grace and power. First, you see the fins, two elegant, wing-like membranes on the side of a conical mantle, beating with a slow, hypnotic pulse that propels the creature forward. Then, the body, a torpedo of muscle and intelligence, the color of rust and old blood. And then the eye. It swivels to regard you, an eye the size of a dinner plate, a perfect, luminous orb of liquid gold and unfathomable complexity. It is the largest eye in the animal kingdom, an organ evolved to capture the faintest whispers of light, the ghostly flickers of bioluminescence that are the only language of this world. In its depth, you feel a profound, alien intelligence. This is the giant squid, Architeuthis dux, the Kraken of myth, made real. It hangs in the water before you, a being of pure, fluid power. 2 of its 10 arms are dramatically longer than the others, twin tentacles that can be shot out with lightning speed to capture prey. The others, shorter and lined with suckers, writhe gently, like a collection of curious serpents. This creature is not a bottom dweller, bound by sediment and gravity. It is a king of this three-dimensional space, a realm without boundaries, without up or down, without any solid ground to constrain it. Here, in the largest habitat on Earth, size is not a hindrance, but a liberation. It can grow to fill the space, unburdened by the need to support its own weight against gravity, a luxury afforded by the dense, supportive medium of the water. Its gigantism is one of length and reach, a body plan designed to dominate a vast, empty volume of hunting ground. You feel the faint pressure wave as it expels a jet of water and glides away, a silent phantom disappearing back into the ink from which it came, leaving you with a profound sense of wonder. Your gaze drifts back to the seafloor and you notice a different kind of titan, one that embodies yet another strategy for achieving immense size. At first, you might mistake it for a strange skeletal plant or a piece of sunken wreckage. A collection of long, impossibly thin sticks seems to rise from the mud. But then one of the sticks moves. And another. You realize you're looking at the legs of the Japanese spider crab, Macrocheira camphori. This creature is gigantism expressed as a sprawling architecture. Its central body, its carapace, may not be much larger than that of the giant isopod. But its legs are a marvel of biological engineering. They stretch outwards, slender and jointed, giving it a leg span that can reach nearly 4 meters, the width of a small car. It is a delicate, stilt-walking giant, a living cathedral of chitin. It moves with a slowness that feels geological, as if it is measuring its steps in epochs. Its great size allows it to cover vast distances on the seafloor with minimal effort, striding over obstacles, its spindly form a perfect adaptation for probing and scavenging across the soft plains of the abyss. Its fragility seems a paradox in this place of crushing force, but like the isopod, its body is full, and its structure is designed to distribute stress, not resist it head-on. It is a creature woven from patience and pressure, a living sculpture that redefines what it means to be large. You have now witnessed 3 of the kingdom's subjects, the armored knight, the phantom king, and the walking cathedral. Each one is a unique answer to the same question. They are not monsters, but masterpieces of evolution, each one a clue in the great, unfolding mystery of deep-sea gigantism. They have shown you that size can be expressed as armor density, as fluid power, or as architectural grace. Seeing them, feeling their presence in the deep, quiet dark, the question no longer feels purely scientific. It feels poetic. How does this world of immense, compressive force, this world that should stifle and shrink, become the very cradle of giants? Section 3. The slow dance of cold. As the phantom image of the giant squid dissolves back into the blackness, and the spider crab continues its geological ballet on the seafloor below, you become aware of another fundamental truth of this kingdom. It is not a presence you see, but one you feel, a quality that permeates every molecule of water around you. It is the cold. This is not the sharp, biting cold of a winter wind on the surface world. That kind of cold is an event, a temporary state. This is different. This is a cold that is eternal, unchanging, and absolute. The water here, thousands of meters from the sun's warmth, hovers at a stable, numbing temperature just a few degrees above freezing, around 2 to 4 degrees Celsius. It is a cold that has seeped into the very fabric of existence, a defining parameter of life itself. And in its unyielding grip, we find the first major clue to the mystery of the giants. To understand this, you must think of life as a rhythm, a tempo. On the sunlit surface, life is a frantic, allegro symphony. The warmth of the sun fuels a fast metabolism, a roaring inner fire in the creatures there. Days are short, seasons change, and the clock of life ticks rapidly. Generations come and go like waves upon the shore. There is a constant urgency, a race to eat, to grow, to reproduce, all before the flame burns out. Down here, in the abyssal dark, the cold is the conductor, and it has slowed the symphony to a near standstill, an adagio of breathtaking slowness. The creatures of the deep are almost universally ectothermic, or cold-blooded. This doesn't mean their blood is literally ice, but rather that their internal body temperature is not self-regulated. It mirrors the temperature of the world around them. Their inner fire does not roar. It smolders, a single, glowing ember in the deep chill. This is because metabolism, the engine of life, is fundamentally a series of chemical reactions. And one of the most basic principles of chemistry is that cold slows reactions down. Think of honey in a warm room, how it flows freely. Now picture that same honey in a refrigerator. It becomes thick, viscous, and reluctant to move. The cold of the deep sea has the same effect on the very chemistry of life. The processing of food, the repair of cells, the firing of neurons, every single biological process is stretched out, elongated in time. Now, consider the profound consequences of this. If the inner fire, the candle of life, burns at an incredibly slow rate, the candle itself lasts for an incredibly long time. The first gift of the cold is the gift of time. Lifespans in the deep sea can be staggering. The Greenland shark, which patrols the cold waters of the deep North Atlantic, can live for over 400 years, making it the longest living vertebrate on Earth. The giant isopod you saw earlier may live for half a century. Certain deep-sea corals and sponges are among the oldest living organisms on the planet, with some colonies estimated to be thousands of years old, silent witnesses to the entirety of human history passing in the world of light far above. This extended lifespan is the first part of the equation. The second part is a biological principle known as indeterminate growth. You, as a human, are a determinate grower. You grow rapidly as a child and adolescent, and then at a certain point you stop growing taller. Your body plan is complete. But many creatures, particularly fish, mollusks, and crustaceans like the ones you have encountered, are indeterminate growers. They continue to grow, albeit more slowly, for their entire lives. They have no genetic off switch for growth. And now, in the patient quiet of the abyss, the two pieces of the puzzle click together. The cold slows down metabolism to a crawl. This slowed metabolism leads to an extraordinarily long life. This long life, combined with a body plan of indeterminate growth, creates a perfect recipe for gigantism. The giants of the deep are not growing faster than their shallow water cousins. In fact, they are growing much, much more slowly. But they're growing for longer. A giant isopod is not a creature that grew to the size of a football in a year. It is a creature that has been slowly, patiently accumulating size over decades, like a crystal forming in supercooled water, one molecule at a time. The Japanese spider crab did not sprout its 4-meter leg span in a growth spurt. It is the product of a century or more of unhurried, incremental expansion. Gigantism, in this context, is not a sign of vigorous, rapid life. It is the opposite. It is a monument to slowness. It is the physical manifestation of time itself stretching out. These creatures are living time capsules, their immense size a testament to the sheer number of sunrises and sunsets they have never seen. They are old, profoundly old, and their size is simply the accumulated result of their age in a world where growth never ceases. The crushing pressure and the profound cold are not opposing forces. They are silent partners. The pressure shapes the form of life, demanding robust, fluid-filled bodies. The cold shapes the tempo of life, granting the time needed for those forms to achieve a majestic scale. You are floating in a planetary refrigerator, a great, dark cradle where the clock ticks so slowly that life can patiently, over centuries, sculpt itself into a giant. The first secret is out, not shouted, but whispered in the penetrating chill. To grow large, first, you must learn to wait. Section 4. The breath of the abyss. You are drifting in this kingdom of cold and shadow, with the first piece of the puzzle, the gift of time, settling into your understanding. The cold slows the rhythm of life, allowing for decades and centuries of unhurried growth. It is an elegant and powerful explanation, and yet it feels incomplete. A long life provides the opportunity for growth, but growth itself requires fuel. It requires energy. And in the living world, the primary currency of energy is oxygen. Imagine life as a fire. We have established that the cold makes this a very slow-burning fire. But even the slowest burning ember requires air to smolder. Without oxygen, the fire, no matter how patient, will be extinguished. The creatures of the surface world live in an oxygen-rich environment, bathed in air or in warm waters that are churned by winds and waves, constantly mixing with the atmosphere. But down here, thousands of meters below that turbulent, life-giving surface, how does the breath of life reach these depths? It seems like a paradox. The deeper you go, the farther you are from the source of oxygen atmosphere and the photosynthesizing plankton that live in the sunlit zone. You might expect the deep ocean to be an anoxic wasteland, a stagnant pool where oxygen has long been used up. In some specific areas of the ocean, this is true. There are oxygen minimum zones, areas where life is scarce precisely because of this lack. But the vast abyssal plains, the very home of our giants, are surprisingly and crucially oxygen-rich. To understand this, you must picture the Earth as a living, breathing system with a circulatory system of its own. This is the Great Ocean Conveyor Belt, a planet-spanning current known as thermohaline circulation. It is a process of immense scale and epic slowness, a current driven by heat and salt. Picture the polar regions, the Arctic and the Antarctic. Here, the water at the surface becomes intensely cold. As seawater freezes, it expels its salt, so the water that remains becomes not only colder but also saltier. This combination of extreme cold and high salinity makes the water incredibly dense. It becomes heavier than the water beneath it, and so it sinks. This is not a gentle settling. It is a massive, planetary-scale cascade. Torrents of cold, salty, and most importantly oxygen-rich water plunge from the surface down into the abyss. This water has just been in contact with the polar atmosphere, and it is saturated with dissolved oxygen. As it sinks, it carries this life-giving gas with it, a great, deep breath taken by the planet itself. Once it reaches the bottom, this dense water begins to spread, creeping along the contours of the ocean floor, a slow-motion river flowing through the deep. It will travel for centuries, even a millennium, carrying its precious cargo of oxygen across the globe. This is the breath of the abyss. This is the ventilation system for the deep, dark world. It is the reason why a creature living 4,000 meters beneath the Indian Ocean can breathe oxygen that was last in the atmosphere near Antarctica 500 years ago. Now, let's connect this back to our giants. We have the cold, which slows down the demand for oxygen. A giant isopod's metabolism is so slow, its need for oxygen is a mere fraction of a similarly sized warm water creature. The demand is low, but thanks to this great, planetary circulatory system, the supply of oxygen is surprisingly high. This combination is another key to the kingdom. It creates a uniquely favorable environment for growing large. In warmer, shallow waters, a larger body size often comes with a metabolic cost. A bigger animal needs more oxygen, and sometimes the environment can't supply it fast enough, especially if the water is warm and holds less dissolved gas. This can limit the maximum size a creature can attain. But in the deep, this limitation is lifted. The low metabolic rate means that even a very large animal does not experience respiratory distress. It doesn't struggle to get enough oxygen to fuel its massive frame. The cold, oxygen-saturated water provides a stable, abundant supply that is more than sufficient to meet the slow, simmering demands of its biology. Think of it as a biological budget. The cold drastically reduces the body's expenses. The thermohaline circulation provides a steady, reliable income. With low expenses and a stable income, the body can invest its resources elsewhere, specifically into growth. It allows for the construction and maintenance of a large, complex body without the risk of running an energy deficit. So, when you see the giant squid with its plate-sized eye and its powerful mantle, remember that every cell in its vast body is sustained by this ancient, traveling oxygen. When you watch the spider crab meticulously pick its way across the silt, know that its slow, deliberate movements are powered by a breath that began its journey at the frozen poles centuries ago, during a different chapter of human history. The gigantism of the deep is not just about time. It is also about this perfect, delicate balance between supply and demand. The cold provides the time. The planet's own circulatory system provides the breath. It is a synergy of colossal forces, the chill of the abyss and the slow, beating heart of the ocean currents. These forces, working in concert over millennia, have created a haven where the ember of life can not only smolder for centuries, but can also be supplied with just enough air to patiently build itself into a titan. The giants are not just products of their local environment. They are children of the entire planetary system, shaped by a process as vast and slow as the turning of the world itself. Section 5. Forged under pressure. You are suspended in the deep, a silent observer in this realm of paradox. You understand the gift of time, bestowed by the profound and eternal cold. You understand the gift of breath, carried on ancient currents from the frozen poles. These elements create the conditions for gigantism, the stage upon which it can unfold. But as you float here, a presence you first met on your descent makes itself known again, not as a number, but as a feeling. It is the pressure, the immense, relentless, and all-encompassing weight of the world's water. We have treated it thus far as a hostile force, a challenge to be overcome, a filter that allows only the most specialized life to pass. Our intuition, born of a world of light air, tells us that pressure constricts, it compresses, it crushes. It is a force of diminishment. But now, let us entertain a radical, counterintuitive idea, a secret whispered by the very physics of this place. What if the pressure is not just a passive filter? What if it is an active sculptor? What if this immense force, in some strange and wonderful way, actively favors largeness? To understand this, we must shrink our perspective, journeying from the colossal scale of the Kraken down to the microscopic, to the very building blocks of life. The individual cell. Imagine a single, simple cell from a creature of the sunlit surface. Let it begin the same descent you took. As it sinks, the hydrostatic pressure begins to exert its influence on the cell's most crucial boundary, its membrane. This membrane is a fluid, dynamic thing, a delicate bubble of lipids that keeps the chaos of the outside world separate from the intricate order within. But under the growing pressure, this fluidity begins to fail. The pressure squeezes the lipid molecules closer together, making the membrane more rigid, more viscous, like oil chilling into wax. Its vital functions transporting nutrients in, ushering waste out begin to slow down and fail. The pressure also infiltrates the cell's interior, interfering with the most delicate of all biological ballets, the folding of proteins. Proteins are the microscopic machines of life, and their function depends entirely on their complex, three-dimensional shape, a shape as specific and crucial as that of a key to a lock. Pressure can disrupt the subtle forces that hold these shapes together, causing them to misfold or unravel, rendering them useless. For a surface cell, the deep is a place where its very structure and chemistry are under siege. Now, picture a cell that has evolved here, a cell born of the abyss. It is different. Scientists who have studied these remarkable cells have found a fascinating trend. They are often significantly larger than their shallow water counterparts. This is not just a coincidence, it is an adaptation. It is a direct answer to the challenge of pressure. Consider the geometry. A larger cell has a lower surface area to volume ratio. Think of it as a fortress. A larger, more spherical fortress has less wall to defend for the amount of space it encloses. For a cell, this means that for every unit of precious, life-sustaining volume inside, there is proportionally less membrane surface under direct assault from the pressure outside. This makes the cell a more stable, more efficient container. It is less leaky, requiring less energy to maintain the delicate chemical balance between its interior and the crushing world beyond. This cellular efficiency is the first stroke of the sculptor's hand. But the pressure's influence goes deeper into the very rhythm of life we have already discussed. It has been observed in laboratory experiments that for some deep-sea species, increasing the pressure actually lowers their metabolic rate, independent of the cold. The pressure itself acts as a brake. It physically constrains the molecular movements required for rapid chemical reactions. Here, a stunning convergence of theories begins to appear. We thought the cold was the sole conductor of the slow symphony. Now we see the pressure is playing the same tune. The cold and the pressure are partners, two immense forces working in concert to enforce a slow, deliberate, and incredibly efficient pace of life. A larger cell, being a more stable and less leaky vessel, is metabolically cheaper to run under high pressure. Its slow, pressure-dampened metabolism sips energy rather than gulping it. Evolution is, at its heart, a ruthless accountant, always favoring the most energy-efficient solution. In the deep sea, where food can be scarce and every calorie is precious, this efficiency is paramount. If a larger cell is more stable and metabolically cheaper under immense pressure, then natural selection will favor the evolution of larger cells. And from there, the logic scales up, from the microscopic to the majestic. If the most efficient building block is a large cell, then it follows that an organism constructed from these large, efficient cells may itself achieve a larger overall size. The gigantism we see is not just a matter of living for a long time. It is a solution that begins at the most fundamental level of biology. The titans of the deep are built from titan cells. Their grandeur is a bottom-up phenomenon, forged in the crucible of pressure itself. Think again of the creatures you have met. The giant isopod, a triumph of robust, armored engineering, its body a collection of large, stable, and incredibly efficient cellular fortresses. Consider the giant squid, whose nervous system contains some of the largest neurons in the animal kingdom. Giant axon cells, so large they were first used by scientists to understand the very nature of how nerves fire. Their size is not just a curiosity, it is likely a functional necessity, an adaptation for rapid signal transmission in a body that is both massive and operating under the dual constraints of cold and pressure. The pressure is not the cage. It is the forge. Like a blacksmith's hammer, it is a force that seems destructive, but in its repeated, insistent application, It strengthens, tempers, and refines. It has beaten away the fragile and inefficient, and in their place, it has forged structures of profound strength and scale. It has shaped life that is not just surviving the pressure, but is using it, life whose very size is an elegant response to the most powerful force in its world. The giants are not prisoners of the abyss. They are its masterpieces. Section 6. The Feast or Famine Principle. You continue to drift in the deep, the water a thick, velvet cloak of cold and pressure around you. You've contemplated the gifts of time and breath, and the surprising role of pressure as a forge for cellular giants. But there is another, more primal aspect to this kingdom, a truth that governs all life, from the sunlit surface to the deepest trench. It is the search for food. In the world, the sunlit world, the base of the food chain is a lush, green meadow of life. Photosynthesis, powered by the sun, creates a constant, abundant supply of energy in the form of plants and phytoplankton. This supports a complex and crowded pyramid of herbivores, carnivores, and scavengers. Food in many places is plentiful. The challenge is not finding it, but competing for it. Down here, the sun is a forgotten myth. Photosynthesis is impossible. The great green meadow is gone. So what do these giants eat? Where does the energy required to build and maintain these colossal bodies come from? The answer drifts down from above, a slow, continuous, and yet profoundly sparse blessing from a distant world. It is called marine snow. Look closely at the darkness around you. In the focused beam of your imaginary light, you can see it, a constant, gentle, and almost imperceptible downward drift of tiny particles. These are not snowflakes of ice, but of organic matter. They are the decaying remains of phytoplankton and zooplankton, the shed skins of crustaceans, fecal pellets, the dust and debris of the vibrant, chaotic world of light, thousands of meters above. For the small creatures of the abyss, this marine snow is the manna of the deep, a thin, but constant, rain of sustenance. But this gentle snowfall of calories is not enough to build a giant. It is a diet for the small and the patient. To build a body the size of a giant squid or a Japanese spider crab, you need a feast. And feasts in the deep are rare, unpredictable, and monumental events. This is the core of the feast or famine principle. Life in the abyss is a life of extreme patience, punctuated by moments of extraordinary gluttony. Imagine a great whale, a leviathan of the surface world, living its life in the sunlit waters. It breathes the air, it feeds on krill, and then its long life comes to an end. Its immense body, a mountain of bone, blubber, and muscle, begins its final journey. It sinks. It falls through the twilight zone, past the realm of bioluminescent wonders, and continues its descent into the crushing dark. This event, known as a whale fall, is one of the most important in the deep-sea ecosystem. It is a delivery of unimaginable bounty, an injection of millions of calories into a world defined by scarcity. The arrival of the whale fall is like a dinner bell rung across miles of barren seafloor. The scent, carried on the slow currents, summons the denizens of the deep. First to arrive are the mobile scavengers, the sleeper sharks, and the giant isopods. They are built for this moment. They will gorge themselves, eating so much that their bodies swell and distend. A giant isopod might eat so much in one sitting that it becomes too buoyant to stay on the seafloor, floating up helplessly before slowly sinking back down. This single feast may be all the food it consumes for a year, or even longer. This is where being large becomes a crucial advantage. A larger body is a larger storage container. It is a biological warehouse for energy. A giant creature can consume a massive amount of food when it becomes available, storing the energy in its tissues, its liver, its very cells, and then slowly, methodically metabolizing that energy over an immense period of famine. A small creature might eat its fill, but its fill is not enough to last for years. It must find another, smaller meal sooner. The giant, however, has bought itself the most precious commodity in the deep: time. Time to wait for the next unpredictable feast. So, the scarcity of food, another seemingly negative factor, becomes another selective pressure in favor of gigantism. Evolution here favors the body plan that can best endure the long, empty stretches. It favors the marathon runner, not the sprinter. It favors the patient gourmand, not the daily grazer. This principle extends beyond the great whale falls. A large tuna, a swordfish, even a great white shark that dies in the upper ocean will eventually make this journey. Large trees and logs, washed out to sea by rivers and storms, can also sink, providing a different kind of feast for specialized, wood-boring creatures. Each of these windfalls is a lottery ticket, and the creatures with the largest bodies are the ones who can cash in the prize most effectively. Think of the giant squid. It is not a scavenger, but an active predator. Yet it too is a creature of feast and famine. It may go for long periods without encountering prey in the vast, empty water column. But when it does find a large fish or another squid, its size and power allow it to subdue a substantial meal. Its large, complex digestive system can then process this meal slowly, efficiently, fueling its massive body for the long, patient hunt to come. Its gigantism is an investment in predatory success in a low-density world. The deep is not a gentle pasture. It is a desert punctuated by rare and magnificent oases of nutrient wealth. The giants are the camels of this desert. Their immense size is not a sign of gluttony in a world of plenty, but a profound adaptation to scarcity. It is a strategy of hoarding, of patience, of making the most out of magnificent but fleeting opportunities. The pressure forges their cells, the cold grants them time, the currents give them breath, and the vast, empty spaces punctuated by rare feasts demand that they grow large enough to endure the waiting. Each challenge of the deep, when you look at it through the lens of evolution, seems to turn into another reason for being a giant. Section 7. An empty throne, a growing king. You have felt the pressure, the cold, and the profound hunger of the deep. You understand how these physical and metabolic drivers have shaped the titans of this kingdom. But there is another dimension to their world, one that is less about physics and chemistry and more about the invisible tapestry of relationships between living things. It is the dimension of ecology, the grand and complex game of who eats whom. On the sunlit surface, in the vibrant coral reefs or the teeming kelp forests, life is a crowded, dangerous affair. The water is thick with predators. Every creature, from the smallest shrimp to the largest seal, is both a hunter and the hunted. Size is often an advantage, but it is not a guarantee of safety. There is always a bigger fish, a faster shark, a more cunning hunter. The evolutionary pressure from predation is immense, a constant arms race that shapes bodies for speed, for camouflage, for defensive armor, or for venom. In this crowded world, growing too large can sometimes make you a more conspicuous target. Now, let us return to the abyss. As you descend, something remarkable happens to this web of predation. It thins out. The sheer lack of energy, the sparse rain of marine snow, simply cannot support the same density of predators that the sunlit world can. The great, fast-moving, warm-blooded hunters of the upper ocean, the tunas, the billfish, the dolphins, the great white sharks cannot function in this cold, dark, low-energy world. Their high-octane metabolism would burn out in days. They are creatures of the sun, and their reign ends where the light ends. The result is a world with a power vacuum. The throne of the apex predator, so fiercely contested in the shallows, is largely vacant in the deep. This is not to say there are no predators here. You have met the giant squid, a formidable hunter. There are the great, slow-moving Greenland and sleeper sharks, ancient and patient predators. But the overall intensity of predation, the constant, moment-to-moment risk of being eaten, is dramatically reduced. This ecological release from predation is another powerful, and perhaps unexpected, driver of gigantism. It changes the rules of the game. In a world with fewer effective hunters, one of the primary disadvantages of being large, visibility is lessened. And one of the primary advantages of being small, the ability to hide, becomes less critical. Consider again the Japanese spider crab, with its astonishing 4-meter leg span. In a shallow, predator-rich environment, such a creature would be an obvious and vulnerable target. Its slow, deliberate movements would make it an easy meal for a fast-moving shark. But in the deep, its main predators are few and far between. Its sheer size becomes its primary defense. What predator in the deep has a mouth large enough, or a body powerful enough, to tackle such a sprawling, armored giant? It has effectively outgrown its enemies. Its gigantism is not just a result of long life and slow metabolism, it is a strategy made viable by the emptiness of the landscape around it. It has become the king of its own, quiet corner of the world simply by becoming too large to challenge. Think also of the giant isopod. Its heavy, calcified armor is certainly a defense. But this armor is metabolically expensive to build and to carry. In a world with intense predation, there would be an evolutionary trade-off between being heavily armored and being fast enough to escape. But in the slow-paced, predator-scarce abyss, the isopod can invest fully in its fortress-like body without being penalized for its slowness. It has no need to run, so it can afford to be a tank. This principle is sometimes called the island effect, observed in terrestrial ecosystems. On remote islands with no large predators, birds that were once small and flighted, like the dodo, sometimes evolved to become large and flightless. Without the need to escape, they could abandon the energetically costly apparatus of flight and invest that energy into growing larger, dominating the island ecosystem. The deep sea is, in an ecological sense, a vast, dark island. It is isolated from the high-energy predator-prey dynamics of the surface world, allowing its inhabitants to follow unique evolutionary pathways. So, gigantism here is not just an adaptation to the physical environment, but also to the biological one. It is a response to absence as much as it is to presence. It is a consequence of the silence, the lack of a chase, the empty throne. The creatures of the deep can dedicate their energy budget, already managed so carefully due to the cold and the pressure, almost entirely to growth and longevity, rather than to the frantic, moment-to-moment struggle for survival that defines the world above. They grow large because, in a very real sense, nothing is stopping them. The evolutionary checks and balances that might keep size in check in a more crowded ecosystem are simply not in place. They are the lonely monarchs of a vast and quiet kingdom. Their immense size is a coronation, a claiming of the empty throne in a world where the primary challenge is not being eaten by another, but simply finding enough to eat for oneself. They have become the biggest fish in a truly enormous, but very empty, pond. Section 8. A Symphony of Causes. You have traveled far on this journey, sinking through pressure, time, breath, hunger, and silence. You have gathered the clues, each one a thread in a grand, intricate tapestry. There was the cold, the great conductor slowing the tempo of life, granting the gift of centuries. There was the breath of the abyss, the oxygen-rich currents providing the fuel for the slow-burning fire. You felt the pressure, the sculptor's hand, forging larger, more efficient cells. You understood the stark reality of feast and famine, favoring the patient giant who could store a banquet for an age. And you have just visited the empty throne, the ecological silence where growing large is a coronation, not a risk. Each of these threads, on its own, offers a compelling reason for the existence of giants. It would be tempting to choose one, to declare it the single, definitive answer to the mystery. Perhaps it is all about the cold. Or maybe it is simply the lack of predators. Science, like the human mind, often seeks the simplest explanation, the one elegant key that unlocks the entire puzzle. But as you float here, in the profound and complex dark, you begin to feel that such a simple answer would be a disservice to the majesty of what you have witnessed. The titans of the deep are not the product of a single cause. They are the grand finale of a symphony, a masterpiece born from the interplay of every single one of these forces, all acting in perfect, harmonious concert. This is the principle of synergy, where the whole is far greater than the sum of its parts. The explanations for deep-sea gigantism do not compete with one another. They amplify one another. They are woven together so tightly that to pull on one thread is to feel the tug of all the others. Let's trace these connections. Watch how the symphony builds. The journey begins with the cold. The frigid temperature slows metabolism down to a crawl. This is the foundational rhythm, the slow, steady bass note of the composition. A slow metabolism immediately leads to a longer lifespan, giving indeterminate growers the sheer time needed to accumulate size. But this slow life would be impossible without the steady supply of oxygen brought by the great ocean conveyor belt. This is the breath of the symphony, the life-giving wind section that sustains the long notes. The cold water's ability to hold more dissolved oxygen is a crucial harmony. So, the cold not only slows the demand for oxygen, but also enhances its supply, a perfect duet. Into this slow, oxygenated world, add the immense pressure. The pressure, as we discovered, also helps to lower metabolic rates, reinforcing the effect of the cold. It's like the conductor telling two different sections of the orchestra to play at the same, slow tempo. Furthermore, the pressure selects for larger, more stable cells, providing a more efficient, robust building block for life. This is the deep, resonant percussion of the forge, shaping the very instruments of the orchestra. A creature with a long life, fueled by ample oxygen, is now being built from superior materials. Now, layer on the challenging melody of feast or famine. This sparse food supply would be a death sentence for a fast-burning, inefficient organism. But for our slow-metabolizing giant, built of pressure-resistant cells, it becomes just another reason to be large. The long lifespan allows it to wait for a meal, and its large body allows it to store that meal for an immense period. The scarcity of food does not contradict the existence of giants, it necessitates it. It is the challenging, beautiful violin solo that gives the piece its dramatic tension. Finally, let this all play out on the stage of a predator-scarce ecology. The empty throne. This is the acoustics of the concert hall itself. In a different venue, a predator-rich one, this slow-moving, large-bodied creature might be too vulnerable. Its symphony would be cut short. But here, in the vast, silent cathedral of the abyss, its song can play out to its full, magnificent conclusion. The lack of predators removes the evolutionary penalty for being large and slow, allowing the synergistic effects of cold, oxygen, pressure, and food scarcity to reach their ultimate expression. You cannot isolate any one factor. Without the cold, life would be too short. Without the oxygen, it would suffocate. Without the pressure-adapted cells, it would be too inefficient. Without the feast or famine strategy, it would starve. And without the ecological release, it would be hunted into a different evolutionary shape. Deep-sea gigantism is not a lock with a single key. It is a combination lock, and every single number must be dialed in perfectly. The cold, the breath, the pressure, the hunger, the silence, they are the numbers in the combination. And when they align, the vault of evolutionary possibility swings open, and a giant emerges. This is a more complex and, perhaps, a more satisfying truth. It speaks to the profound interconnectedness of the natural world. It shows us that the most magnificent expressions of life are rarely the result of a single, simple cause, but rather the emergent property of a complex system where every element influences every other. The giants of the deep are not just biological curiosities. They are living, breathing lessons in synergy. They are the sound of the entire abyss, all its forces and all its secrets, playing a single, majestic chord. Section 9. Our Eyes in the Deep. As the symphony of causes settles into a profound and resonant harmony in your mind, a new awareness begins to dawn. It is the awareness of yourself. You, the silent observer, floating in this impossible world. How are you here? How is it that a creature of air and light, a being so utterly unsuited for this realm, can bear witness to its deepest, darkest secrets? Your presence here, even in imagination, is a testament to another kind of titan, a different kind of marvel forged not by evolution over eons, but by human ingenuity over decades. It is a testament to the insatiable curiosity of the human spirit, a force as powerful, in its own way, as the crushing pressure of the abyss. You are here because we, as a species, refuse to accept the darkness as a barrier. We decided to build eyes that could see in the eternal night and bodies that could withstand the weight of an ocean. Picture them in your mind, these ambassadors of humanity, these proxies for our own fragile bodies. They are the submersibles and the remotely operated vehicles, the ROVs. They are our extensions of self, our avatars in this alien world. Imagine first the storied lineage of crewed submersibles, vessels like Alvin or the Deep-Sea Challenger. These are not mere machines. They are cocoons of life support, tiny pockets of the surface world sent on a heroic journey into the deep. Picture the quiet hum of their electronics, the gentle hiss of the oxygen scrubbers, the faint taste of recycled air. Inside, a pilot and scientists sit in a small titanium sphere, a perfect shape for distributing the immense pressure evenly. Titanium, a metal as strong as steel but much lighter, is one of the few materials that can withstand this environment without being impossibly heavy. The sphere is our armor, our isopod shell, protecting the fragile, air-filled beings within. Through small, thick quartz Windowsa material so strong it can stare into the abyss without flinching, scientists peer out. Their own eyes, which evolved to see for miles in sunlit air, are now pressed against this portal, trying to make sense of a world illuminated only by the submersible's powerful, stark beams. These lights cut through the darkness, creating a moving stage, a circle of temporary day in the eternal night. And in this circle, the giants appear. The scientists are not just seeing an image on a screen, they feel the presence of these creatures. They might see a giant squid, its eye returning their gaze with an intelligence that feels both ancient and immediate. They are there, sharing the same water, separated only by a few inches of metal and glass. It is an encounter as profound and as personal as meeting a lion on the savannah. Then there are the uncrewed explorers, the ROVs. These are our true robotic avatars, our telepresence in the deep. Imagine a machine the size of a small car, bristling with cameras, lights, thrusters, and delicate manipulator arms. It is connected to a research vessel on the turbulent surface by a tether, a lifeline that can be thousands of meters long. This tether is a marvel in itself, a bundle of fiber-optic cables and power lines that serve as the ROV's nervous system and umbilical cord. On the ship above, in a darkened control room, the pilots fly the ROV. They are not looking through a window, but at a bank of high-definition screens that show them what the robot sees. With joysticks and complex controls, they navigate the abyssal plains, fly up the sides of undersea mountains, and hover over hydrothermal vents. Their touch is precise, their movements guided by years of experience. They are explorers who have never left their chairs, yet they have charted more of this alien world than any human in a submersible. The ROV's manipulator arms are the hands of the scientists. A pilot, sitting in a climate-controlled room, can guide a robotic claw to gently pick up a delicate sea sponge, to collect a sample of ancient sediment, or to place a sensor on the seafloor. It is a form of remote surgery on the planet itself. They can zoom in with their cameras to see the intricate details on an isopod shell or the strange, bioluminescent lures of an anglerfish. They are our senses, amplified and extended, capable of touching, seeing, and sampling a world we can never physically inhabit. It is a beautiful and poignant duality. The giants of the deep, like the giant squid, have evolved the largest eyes in nature to capture the faintest photons of biological light. We, the primates from the bright savanna, have evolved the minds to create our own light, our own eyes of glass and electronics, to shine into their world and meet their gaze. It is a conversation between two entirely different forms of intelligence, two completely different solutions to the challenge of existence, meeting across an almost unimaginable gulf of environment and evolutionary history. Your journey tonight, your ability to witness these marvels and contemplate their meaning, is made possible by this spirit of exploration. Every fact we've discussed, every theory we've explored was hard-won by these missions. They are born from the courage of the pilots, the patience of the scientists, and the brilliance of the engineers. These machines are more than just tools. They are monuments to human curiosity. They are the physical embodiment of our need to know, to understand, to see what lies beyond the edge of our own world. And as they glide silently through the crushing dark, their lights sweeping across the titans of the abyss, they are not invaders. They are pilgrims, paying respect to a kingdom of life that is as magnificent and as mysterious as the stars above. Section 10. The Unanswered Echo. Our journey is nearing its end. We have descended through the crushing weight of the ocean, felt the profound, life-altering cold, and learned to breathe the ancient, traveling oxygen of the abyss. We have witnessed the paradox of feasts in a barren desert and explored the silent, empty throne room that allows kings to grow unchallenged. We have seen how these forces intertwine, a grand symphony of causes creating the majestic titans of the deep. And we have honored the human ingenuity that allows us, creatures of the sun, to cast our own light into this eternal night. We have gathered the pieces and assembled them into a coherent story, a narrative that feels satisfying and complete. And yet, as you float here one last time, in the absolute silence and darkness, a deeper feeling begins to surface. It is a feeling of profound humility. It is the realization that our story, as elegant as it may be, is just that, a story. It is our best interpretation, our most educated guess, based on the fleeting glimpses our robotic eyes have granted us. The truth is, the deep sea remains the largest and least explored habitat on our planet. We know more about the surface of Mars than we do about the abyssal plains that cover most of our own world. For every giant squid we have managed to film, how many thousands have lived and died unseen? For every species we have identified, how many more await discovery in the sediment and the water column, with adaptations and survival strategies we cannot yet even imagine? Think of the life we have not even touched upon. The ghostly grenadier fish, or rat tails, that patrol the seafloor in vast numbers, living for over a century. The colossal colonies of deep-sea corals, some living for over 4,000 years, building intricate, tree-like structures in the dark, each branch a record of the passing centuries. Or the enigmatic vampire squid, a creature so unique it has its own taxonomic order, a living fossil that has found a way to thrive in the oxygen minimum zones where other creatures would suffocate. Each one of these is another verse in the epic poem of the deep, a verse we are only just beginning to learn how to read. The theories we have explore the cold, the pressure, the oxygen, the food, the ecology are powerful and enlightening. But they are almost certainly incomplete. Are there other, more subtle forces at play? Perhaps there are genetic factors, ancient predispositions in the DNA of these creatures that prime them for gigantism. Perhaps there are unique biochemical pathways we have yet to discover, specific molecules that protect against pressure or allow for unparalleled metabolic efficiency. Perhaps the very nature of the water itself, its structure under immense pressure, has biological consequences that are still beyond our understanding. The abyss does not give up its secrets easily. It holds them close, in the crushing, cold dark. Every piece of data we collect is a triumph, a single candle lit against an infinite expanse of night. And with every answer we find, a dozen new questions echo back from the darkness. This is not a cause for frustration, but for wonder. It is the beautiful, unending nature of science and exploration. The mystery is the point. The unanswered echo is what calls us back, again and again, to send our brave little machines back down into the depths. It is the quiet whisper that reminds us that our world is so much larger, so much stranger, and so much more wonderful than we know. The giants of the deep are the keepers of these mysteries. They are the living symbols of the vastness of our own planet's unknown. Their immense size is a reflection of the immense scale of our own ignorance. They are a humbling reminder that we are not the masters of this world, but simply one part of a story so grand and so ancient that we may never fully comprehend it. And so, we leave them to their kingdom. We leave the isopod to its patient scavenging, the spider crab to its geological ballet, and the giant squid to its solitary, phantom hunt. We retract our light and let the perfect, velvety darkness reclaim its domain. The questions remain, hanging in the water like bioluminescent motes, a constellation of curiosities to guide future journeys. The greatest secret of the deep sea may be this: its ability to perpetually inspire a sense of awe, to remind us that the age of discovery is far from over. It is still happening, right now, in the silent, magnificent, and giant heart of our own world. Now, let the last of those questions drift away. Feel the gentle current of your own breath, slow and deep. The darkness of the abyss recedes, replaced by the soft, comfortable darkness of your own quiet space. The titans of the deep continue their slow, ancient dance in a world far away, a world of profound peace and silence. Let their patience and their calm be a gift to you tonight. As you settle into your rest, may your dreams be as deep and as full of wonder as the ocean itself. Sleep well,